Here we're looking at quadrilaterals. Quadrilaterals, do you recall the word quad? Here we have 4, and lateral, we're talking about the number of sides we have. So let's go ahead and just start filling this in. Noticing here that we have quadrilaterals. A quadrilateral is a 4-sided polygon. Now, here, our first one we're going to be looking at is right over here. This is one type of quadrilateral. This one is a trapezoid. Okay, one thing to notice about trapezoids is that it has exactly, or at least 2 sides, opposite sides that are parallel to each other. And you'll notice here that we actually use kind of like these little arrowed lines to symbolize that the sides are parallel. So here we have one arrow and another one arrow to show that those ones are parallel. Okay. Another type of trapezoid right over here, we know it's a trapezoid again. This one's a right trapezoid. And because it's a trapezoid, it has to have those 2 parallel lines. And so again, we can symbolize those 2 parallel lines with those little arrows. And more specifically for this one, because it is a right trapezoid, you'll notice that it does have some right angles in it. So here we have our right angles, and these little boxes here are used to symbolize that we have a right angle on each of those corners there. Another type of trapezoid, what we have here, the kind that you normally think more of when you think of trapezoids, it's more of a regular type of trapezoid, is what we call an isosceles trapezoid. The isosceles trapezoid does, of course, again, have parallel lines, and that's again because it is a trapezoid. If it doesn't have it, you don't have a trapezoid. And so here we also have something else. We have some sides that are the same length. And to show that 2 sides are the same length, we actually use just a line for each of them. Since we're talking about these 2 sides being the same length, we put those lines just on those 2 sides. And in this case, they're opposite of each other. Something else to notice with isosceles trapezoids is that they have angles that are the same measurement. Because they're not right angles, we use, instead of using a box, we do use this arch instead. So it's like you're trying to form a circle from one part of the angle all the way to the next part of the angle. This angle right here is the same measurement as this angle, so we could use 1 on each of them to symbolize that they are the same. Now, these 2 on the other side are actually also the same to each other. And because they're the same to each other, but they're different from the ones above it, we want to use something else to represent the exact same idea. But instead of just using 1, we're actually going to use 2 markings. So here, having 2 of them shows that they are the same for each other, but they are different than the other ones. Because of the way that they are, if you look at these 2 that are actually across from each other, across the parallel lines, these 2 angles actually form supplementary angles. And what a supplementary angle is 2 angles that add up to be 180 degrees, or it actually would form a straight line. Okay, so as a quick note down here, we could add here that consecutive interior angles are supplementary. One more thing with this isosceles trapezoid is that our diagonal lines are congruent. So here we have one diagonal from one end to the other, and we have another diagonal from the other end to the other. And because of how an isosceles trapezoid is, the lines of them are congruent, meaning that they are the same. So the same length from here to there as it is from here to the other side. Those are our trapezoids. Let's move on now to the next shape over. The next shape we're looking at is a parallelogram. And with our parallelograms, here we go, like we've said before, parallelogram has to have 2 sets of parallel sides. So again, we can again show that these two opposite sides are parallel to each other by using that arrow. And we know that these two opposite sides are also going to be parallel to each other, but we don't want to use that same one arrow. Otherwise, we're going to be referring to these ones also. So instead of just using one arrow, we'll now use two. So here, adding in these two arrows to represent that this side is parallel to the opposite side. Along with that, we have our lines being the same length. So here, these two opposite sides are the same length. I'll use one line to represent each one of those. And these two opposite sides are also going to be the same length. But again, if I use only one line, that means that it would be the same thing for both of them. Any parallelogram is not necessarily the case, but here we can then use two lines to represent just that. So here, two lines, meaning then that this side and its opposite side are the same length. One line on these ones to show that these opposite sides are going to be the same length as well. Okay. Here, something else to note. We have opposite angles. These two angles are the same. So same idea, we're going to put an arch on one side to the other, one arch from one side to the other to show that the opposite angles are the same measurement. And the same thing is true for the other two. Those two angles are the same measurement, and to show that those two are the same, we're going to use two arches instead. Moving on to the diagonals of it. Here we have diagonals of parallelograms, and here for these things here, because this is for a parallelogram, all these things are true for all parallelograms. Here, the diagonals bisect each other. This means that from one end to the other, for a diagonal, it's going to be split directly in the center of that with the other diagonal. Also, that this diagonal is going to be split directly in the middle by its other diagonal. And that's what it means when we say that diagonals will bisect each other. Going to a certain type of parallelogram, a very specific type of parallelogram here, we have the rectangle. A rectangle, as we know, of course, just because it is a parallelogram, does have opposite sides that are the same length. And we have also the other opposite sides are going to be the same length as well. Okay. It is a parallelogram. So here again, opposite sides are the same length. So we can do again one line for each of the opposite sides there. And the other opposite sides, of course, are also going to be the same length. So there's our two lines for those opposite sides there. And that is just because we are looking at a parallelogram. Now, of course, it's a rectangle, and so one thing that's special about rectangles is that the angles of it are going to all be right angles. And so just like here, the opposite angles are the same, these opposite angles are the same of each other, but you'll notice again that they're very specific and they are actually all right angles. So instead of just doing that arch, we're going to actually use the little box to show that they are right angles. Right over here, again, the diagonals, you'll notice they bisect each other, so they get split from each other right in the center for each of them. Next up, we have another type of parallelogram, and this one is a rhombus. This type of parallelogram is also very special because it is similar to a parallelogram. Well, it is a type of parallelogram. So it does again have the opposite sides. So we can do those to show the opposite sides are parallel. The other opposite sides, of course, again, are going to be parallel. We have, though, that the sides this time are all the same. They have to be the same in order for it to be a rhombus. And so instead of putting one tick mark here, and then two here and two here, since they're all the same, we could do 1, 1, 1, and 1 for all of them. With a rhombus, we have the opposite sides, just like any parallelogram, the opposite angles, are going to be the same measurement, and you can expect that the same thing will be true of the other set right there. So we could do two arches to show that. And then now we also have with a rhombus, the diagonals as well. Basically, it gets split right down the center line here, and this diagonal also gets split right down the center line, so it bisects each other. Now, there's another parallelogram that is very, very special right over here. It is a type of rectangle. It is a type of rhombus. We basically have all those things come together to create our square. Okay? Our square, as we know, has two opposite sides that are parallel. It has another two opposite sides that are parallel. It has all side lengths the same length, just like we have for a rhombus. Okay. It also has that all corners, all angles are going to be 9-degree angles, just like our rectangle. And there we have our square. Notice again, our diagonals do get bisected as well. Last shape here, which is another type of quadrilateral, is our kite. And with our kite, we have a couple of things that are different. This time our two side lengths that are the same are going to be the ones that are adjacent to each other, meaning that they're right next to each other. The other two side lengths are also going to be the same. The other two that are adjacent to each other or touching each other, again, are also the same, but they're going to be different than what we have for the first two. That's the first start of creating the kite. Our diagonals for the kite, there's only one diagonal that is bisected. So you'll notice from one side to the other side, it is split right in the middle of it. But from this diagonal, from here to there, the middle of it, I think, is right about here instead. You'll notice, obviously, it's cut up right here instead. So it doesn't bisect this one, but it does get bisected on this one here instead. Okay, and now here we also have the fact that these two angles are going to be the same. However, these two will not necessarily be the same. If it were, then we probably would end up with something more like a rhombus instead. And there we have it, quadrilaterals.